Hello, my name is Kevin Bonham, and this is the second in a series of video tutorials for using JuliaHub, particularly to transition your data science workflows from R into Julia and using JuliaHub. So in the last video, we talked about how you can take your R code that you run on your local system, and you can upload that along with your data sets onto JuliaHub, run it in RStudio, and get exactly the same results on the web infrastructure using JuliaHub Compute. In this video, we're going to start the process of transitioning from our R code into Julia code. And rather than just jumping straight into Julia, in this video we're going to go through a series of hacks that allow us to run R code in a Julia environment so that we can sort of make the process a little bit more slowly. We can just pull in the parts of Julia that we need to start with, and we can sort of build incrementally over time. So this video is going to have a bunch of hacks, but I'll step through them slowly, and I'll put a bunch of information in the video description so that you can follow along yourself. All right, so in the last video, we ended with a JuliaHub project that contained our Markdown code that we converted into Quarto Markdown. It's the same syntax, just a different file extension. And we have here our longitudinal analysis project. So if you recall, we have our Quarto Markdown file and a couple of CSV files that constitute our data. And we're launching that in RStudio server. At least we were launching it. Now what we're going to do is we're going to launch the same project, but in the Julia IDE, which is a different compute infrastructure that has all the stuff we need to run Julia code. And we're going to sort of adapt that to run our R code inside Julia, as we'll see. So we could come here, click this little drop down here, and launch in Julia IDE. But from now on, we're going to be using this going forward. So I'm actually going to edit the project. So we come here, manage, edit metadata, and switch this to the Julia IDE. So our default, when we hit launch now, is going to launch into the Julia IDE. And IDE stands for, by the way, Integrated Development Environment. So we'll launch that. It'll spin up a new instance, a new server that contains code for running Julia and the Julia IDE, which is based on Visual Studio Code. So once that launches, you can see here we can connect. This will spin up. Again, it takes a little bit of time for the server to spin up the instance that we're going to connect to. But eventually, here we go. So this is Visual Studio Code. So if you haven't used Visual Studio Code before, it's the same software you can run on your desktop, but if you've only used RStudio, or primarily used RStudio, this may be a little unfamiliar. It has all the same components though. So you can see, instead of having our sort of file explorer down here on the right, we have this file explorer up here. You can see our data sets and our Markdown file. We can open our Markdown file. Right now it's just plain text. We're going to fix that in just a moment. But we have all of the same information here. And then down below here we have a Julia REPL instead of the R REPL, the R console. But again, the individual components are the same. So if we want, we can run Julia code, 2 plus 2. It comes out with 4, and I'll show you how we can integrate this with our code in just a moment. So here we have our Quarto Markdown, but at the moment, when you first spin up a Julia IDE on an instance, we don't actually have the machinery that we need to sort of work with these kinds of files. But the Julia IDE has access to the whole Visual Studio Code extensions library. And so within that, there are some extensions that are loaded by default to work with JuliaHub. But if we don't have what we need, we can install it. So here I'm installing the Quarto extension. And then I'm also going to install the R extension. That gives us syntax highlighting and a couple of other useful features. It takes a little while. It's got to query the marketplace. And lots of things, as you might imagine, have the letter R in them. But here, this is what we want, R editor support. I already previously installed it, but you can see here that it's, if you don't have it, you can just hit install here, and it will come up. Okay, so now we've got our packages. If we go back to our File Explorer and we open up our Quarto notebook, now we can see all of a sudden we have these run cell features here, and we have syntax highlighting within R, which is pretty cool. But at the moment, unlike the RStudio environment that we had before, this instance isn't set up to actually run R code. So if we try to run the cell, it's going to come up with some errors. So I'm going to show you how to fix those in just a moment. The first thing to know about Julia is that Julia works really hard to work with reproducible environments. If you run R on your local machine, probably you install packages to a sort of global environment and you don't pay a ton of attention. In Julia, it's really well set up to manage individual environments so that within a folder that contains your code, you have all of the information you need to reproduce exactly the same compute environment with exactly the same packages, etc. The way we do that is using the integrated package PKG, which manages Julia packages and manages environments together. And so there's a couple of ways we can do that. If you're used to doing like install.packages in R, you can use the Julia package, PKG package, by saying using package, and then you can say pkg.add to install individual packages. But you can also use something that's integrated into the REPL, the read eval print loop that we're in here, called the package REPL. And so to do that, what we do is we type the close square bracket. So this symbol here, if we press that, you can see that the prompt changes, and we now have the package REPL open. This shows the name of our the environment that we're using. Right now, it's on v1.10, which is the sort of global environment for Julia version 1.10, but we can activate our current directory, our current environment, by typing activate and then dot for the current directory, or / to say the current environment we're in, we want to activate it. And when we do that, you can see it tells us that we're activating a project at this path, which is here, and the name of our little prompt here changes to code, because that's the name of the folder. So by default, it just uses the name of the folder. And then once we're here, we can add packages just by typing add and then the name of the package. The first package we're going to install that's going to help us set up our R environment is something called conda pkg. This is a really neat package that integrates with the conda package manager. It's used a lot for Python, but it's also got R and a lot of other things. And so we can add that package. This goes and queries the Julia general repository to look for the package, and then it's going to install it to our current project. So it's going to go through a bunch of stuff, and it's now installed. So something else happened that you wouldn't see in an R environment, but we're seeing here, which is that two new files were created inside of this environment: the project.toml and the manifest.toml. So the project, all this has is it has a line that says deps for dependencies. So that's the dependencies of this project, and the name of the package we installed, plus a unique string that is associated with the conda package. Manifest.toml contains the entire specification for this project. So we only added one, what's called a direct dependency, but conda package depends on a bunch of other packages. Those are called indirect dependencies. Manifest.toml has exactly the versions, exactly all of the information we need to reproduce this environment specifically, which is pretty cool. You don't need to ever edit, and you shouldn't ever edit the manifest.toml manually. You can leave Project Toml alone as well, but one thing I'm going to do is I'm going to add a line to our Project Toml to give this project a name and say this is going to be my longitudinal analysis thing. So I make it a string. I'm going to save this. Control S here. And once I do that, you'll actually notice that the prompt in our package REPL has changed now to longitudinal analysis. So that's just a little thing, just to make this a little nicer. You definitely don't need to do that. You can just leave it as code. That's fine. Anytime we install packages now, it's going to update our project TOML and our manifest TOML to make sure that this environment stays reproducible. Another thing to note is that at the beginning of this, we said activate to activate this environment. When you're in the Julia IDE, if you have a project TOML, the project is automatically activated. So you'll notice if you close this server and open it back up, you'll already be in this. So you don't ever have to activate it after the first time, as long as you've installed one package and created a project TOML. All right, so we have our conda package. Now we're going to use our conda package by saying using. So this is the same as saying library and then a package name in R. In Julia, we say using, and we're going to use conda pkg. Okay, so now we've got the package library loaded, and what conda package actually does is it adds functionality to our package REPL. So again, we're going to do the close bracket, close square bracket here, and when we do that, we open up the package REPL, and now we can say conda add, and this uses conda to install the packages that we need. For R, the main package that we need is r-base, r-base. So we're going to do that. Conda is going to create a conda environment. It's going to go look at the conda package repository, or there's a couple of different repositories that conda can look at. It goes and it finds the r-base package, and it's going to install that into our local system. What you'll also notice is that a couple more things were created. One is a conda package.toml. So it creates this dependency, which is similar to our project TOML. And then it's going to install the libraries and all of the stuff that we need for whatever we install into this environment into this .conda.pkg folder inside of our data folder. Excuse me. So this is going to take a little time. We'll speed up, and I'll meet you back when this is done. All right, there we are. We've installed it. And now what we'll notice is if we come back to our longitudinal analysis file, I'll go ahead and try to run this. It's still saying we can't find the R path. So the IDE doesn't know to look inside this .conda package. There's a couple of default folders that it would look like. If you were on your local system, it would probably find it automatically. But in this case, it's not going to do that. So here, we want to find the library inside this conda package and tell VS Code where to find it. Tell the Julia IDE where to find it. So it's inside this .conda.pkg .pixie ends. So we installed it into the default environment. And you can see you've got a couple of different folders in here. The details aren't super important. The ones that matter are the bin folder. This has all of the executables in this environment, one of which is the R executable. And then the other one that matters is the lib file, or the lib directory rather, which contains the R lib directory. So the reason that these matter is because we need to tell VS Code, when it tries to run our code, we need to tell it where to look. And so to do that, we're going to go back into our extensions here. We're going to go back to our R editor support package, and we're going to click the little settings gear icon and go to settings. So this provides our package settings, and in this we're going to add the paths that we need to the libraries that we care about. So one of them is this R lib paths, and here we want to make sure that we use our lib folder here and the path to the R lib folder. So I'm going to come in here and I'm going to copy the path to this library, and I'm going to put that in here where it says R lib paths. I'm going to paste it in here. So this is going to link to this particular directory. And another thing that I'm going to do is, and this will be relevant if you have multiple environments like this. If you want to keep your R settings sort of segregated, instead of setting this for the user, I'm going to set it for the workspace. So rlib paths in my workspace, I'm going to paste this in here, say OK. This creates another little hidden folder here, VS Code, that has some settings specifically for this project. This way, every time I load this project, it'll contain these specific workspace settings. Then I'm going to come down, and there's two more places we need to fill in, one of which, let's see, I think it's bin. Nope. I'm trying to remember. So we have lib paths, and we have way down here. Eventually, here we go. R path. So the R path Linux. This is to the R executable, which again is in conda package, Pixie, environments, default, bin. This is where our executable is. So we're going to come here, find our R executable. Again, I'm going to right click here. Oops. Right click. Why is it not wanting me to right click here? I'm going to say copy path. And I'm going to paste that in here to R path Linux. And then for R term, we're going to do that exact same path. So this, if you have a different R terminal that you like Radeon, in principle, you can install that. But for now, we're just going to use the default R terminal. Again, we're doing this in our workspace settings. So now this is all saved. And now, if I come back here to my longitudinal analysis, if I run this code cell, it should, pop up an R terminal. You can see it. We haven't actually installed any of these packages yet, but I have my R terminal here that I can run R code in. So if I do 2 + 2 here in R, we get our typical outputs. Okay. So in principle, you can try to install packages through this terminal like you would in a normal R session, but in order to keep things a little bit more neatly managed, we're actually going to use conda pkg again from within Julia in order to install the R packages that we need. So we've got tidyverse, broom, ggpubr, and a couple of other things. So I'm going to, over here on the right-hand side, I can go back to my Julia REPL. So these are both running at the same time. And now I'm going to say conda add, and I'm going to install the R packages I need through conda. And the way you do this is basically whatever the name of the R package is, you just put an R hyphen in front of it. So for example, I can do R tidyverse. I can do, I've got to spell it correctly, R broom, R ggpub, R cable extra, although cable doesn't actually work. I'll show you that in a moment, but we'll install it anyway. R patchwork, R LME4, and R LMER test. Okay, so I do that, and again, it's going to go and it's going to look at conda, the conda package repositories, and it's going to try to install all these, and usually it succeeds. So again, this is going to take a while, so I'm going to sit back, speed up this section, and we'll be back in a moment. All right, here we are. We've got all of our packages installed. Now we'll come back to our longitudinal analysis markdown, Quarto markdown. We'll run this cell, and now Quarto is able to run that R code inside of our R REPL, inside of the JuliaHub IDE. So we can, here I've got my old paths here. Can delete that again and run the cell, and the code is being run. Now, there are a couple of downsides to this approach compared to regular RStudio, one of which is, as I mentioned earlier, cable doesn't actually really work out of the box. We can sort of hack that together a little bit, but I'm just going to go ahead and delete these sections and show you that the outputs still work. We just don't have the sort of fancy styling to generate those things in line. You can use Quarto to compile, to preview this notebook, and it'll sort of run through the whole thing and generate the HTML or PDF output or whatever. So you can do that. But here we are. We're running our same R code now within the Julia IDE environment on JuliaHub. And in the next video, we're going to talk about how to start actually transitioning this R code to run this R code from the Julia REPL itself. So I'll see you in the next one.